Okay, let's get going here. It's 6:22. This is video 140, and I'm talking about two themes that are important, factorability and divisibility. When we're doing these polynomials, the kind of math we've been doing here. And the questions are two. There's one they're asking you which one can be factored and which one is divisible by 2x minus 3. And you might be tempted to say, oh, this is the answer, this is the answer. But we're more interested in these cases and why certain ones aren't the answer. And that's often the way we learn a little better. So let me take a step back here and let me look at number one, and which can be, so we're all very attentive to the English, factored. So you're either factorable or you're not factorable. So they're saying three of these are not factorable and one of them is. So they're trying to say no matter what I do, I can't factor three of these and I can factor one. So let's take a look, and we're going to show that 3 is the answer. Look at that for a second. And there are lots of reasons why 3 is the answer, but like I said, we're very concerned about why 1, 2, or 4 wouldn't be the answer. And so we look at number 1, and a lot of kids fall into this trap. They see the x squared, or they see the 1, and they confuse it with the minus. Nobody ever said you can factor this. Here, let's go all the way back to 6th grade and 7th grade. There's x squared, the way they teach it to you back there. And then 1, the only factor of 1 is 1. There's nothing I can match. There's no tricks that I know of with 2 pluses that are going to do anything. This is not factorable. This is a binomial, a quadratic binomial with 2 terms. That's all it is. Okay? All right? For now. Okay, and number 2, I have to dismiss number 2 because although 4 is a perfect square, 15 is not a perfect square. But I don't want to get ahead of myself. Perhaps 4 and 15 share, right? A common factor, but that's only 1. You can do the factoring out yourself and you'll see they share nothing. 3, 5, 2, 2, they don't share anything. So 3 is going to be the answer. I said that right away. And you look at it, well, you say at least I can factor something because 20 and 5 share 5. So I'll put my little thing there. And I factor out as I was taught to do, but I can't factor out the x squared. Oh, but if I take a close look at this, I start to see something I've been looking for all along. There's the negative sign between this binomial. There's a perfect square. And of course, as we've said so many times, 1 is a perfect square. So I can completely factor this one. Not that they asked you to do that, but that would be the kind of skill set, skill level that we'd expect out of our freshmen, okay, going into high school. Now, we know 4 can't be the answer, so the reason is why not? 1's a perfect square, 4 is a perfect square, so the square root of 1 is 1, so I'm just multiplying this times this, and I get 2, and I might be tempted to say, oh, that's the answer. But remember, you have to double the middle term, so it's 2 times 2. So to make it a perfect square, which would be x plus 2 squared, you'd have to add an extra 2x to this. Get used to that idea. You'll be doing that down the road, at least some of you. Okay, so we showed why 3 must be the answer, and we showed why 1, 2, and 4 cannot be the answer. We couldn't factor them. And you're supposed to be understanding the idea of what you can and you can't factor. And those that you can factor that we know about, I'm calling factorable. And I'm defining factorable only by integers, okay? Once we see fractions, we run away. In this particular math, I say. So now we look at the second one, and it says which is divisible. So that means, like, if you divide 2 into 9, you get 4 remainder 1. So we say 9 is not divisible by 2. That's what they mean in this question, okay? There's no remainder by 2x minus 3. So you get the idea that you have to understand thoroughly what they're asking you to do. This divides into this, or this, or this, or this. 3 of them don't work, and 1 of them does. and I'll stand back a second and let you look at it, and I'll get you the right answer, and at the same time, we'll check it the old-fashioned way when we do come up with the answer. So there you're looking at these and you're saying to yourself, well, can't be 1. And for the simple reason that if you put your 2x minus 3 here and you start to divide, 2x doesn't go into 3x. We don't know when you get a fraction on the first term. Sounds crazy. Whatever it is, nobody taught that to me, so it can't be 1, especially when there are 3 other choices. 2x doesn't go into 3x without a fraction. No problem with that here. 2x minus 3 into this. But now there's a big problem, a big, huge problem, and that is every term here is positive. Well, how can you divide a negative into a positive and get 3 positive terms? That doesn't make any sense. And also, if you remember what we taught you, since 4 is a perfect square, and 3 is a perfect square, and 2 times 3 is 6, doubled is 12, we know what the factorization of this is. Not that they asked it to you. That's this, not this. I can't divide this by this and expect no remainder. It's not going to happen. Okay. So now normally in a class we'd ask number 3, anybody want to raise their hand? Don't you see the obvious? Oh, there it is. There are 2 major reasons. 1, everybody's positive, so that's impossible. It has somewhere there has to be a positive times a negative. Follow my drift. And also that 2x doesn't go into 9x without a remainder. So we can safely dismiss the first 3. And now we want to figure out what's going on with number 4. Well, the first thing we see with number 4, forget about what we were asked to divide by. We've been working on this kind of factorization where the middle term is a negative 1, both are perfect squares surrounding it, and we were taught just to do this without thinking about it. Lots of high school kids do. Well, then 2x minus 3 divides 2x minus 3 and cancels. So 4 is clearly the answer that way. But kids have asked me that since it's a divisibility property here, problem asked about that, don't you think you should divide it and show that it must be the answer? So I'll do that over here. And here we see why factorization is so much more powerful than divisibility, because it can get tricky sometimes. So I have to divide 2x minus 3 into 4x squared minus 9. And a lot of kids stumble here. I don't blame them. It's much better to be able to factor than to divide. And so here we have our open space here, okay? And now I look at this, and I got to remember that there's x to the x 0 times x to the 1 here. Keep that in the back of your mind when you do the math. It's easy to get confused. But to start out, 2x goes into 4x squared. 4x squared times 2 times x is minus 6x. Now here you got to be careful. These are not like terms. So this might want to shuffle over here a little bit. And now when you subtract, you get 6x minus 9. Okay? But then 2x goes into 6x 3 times. And we get our desired result. No sweat, no tears. Okay? All right? So those are the kind of questions, at least, that they should be asking you. And I solved that one beyond the shadow of a doubt, showing you what we mean by these things. And a real good test would test your understanding, not just saying factor this, factor that, no matter how difficult they may become. So I'll leave it like that, and we'll post this out to you guys. And this afternoon we'll take care of tomorrow's assignment and what I gave you for the weekend.